Hi, Mrs. McTaggart here, and in this video we are going to be looking at the wave function, and in particular we're going to be looking at what happens when we asked you to do the wave function using the sine expansions. So before this, hopefully you've already watched the videos on how to do the cos expansions. Now we're doing the sine expansions. So it gets ever so slightly more difficult for the first wee bit. So if you haven't seen the cos expansions, go watch those ones first, because it gives you a wee bit more information about why we're doing the wave function, etc. I'm going to go straight into the example. So they ask us to write 2 sine plus 5 cos x in the form k sine x plus alpha. So the first thing we're going to do is we're going to take this and write that out as our expansion. So we're going to write 2 sine x plus 5 cos x equals, and then your expansion for sine is the one that goes sine cos cos sine. It's always a bit symmetrical looking. So this equals k sine x cos alpha plus the sign change stays the same with the sine expansions, k cos x sine alpha. Okay, so it's symmetrical sine cos cos sine. Then we are going to do our equating the coefficients part, the underliney bit as my pupils call it. So we go right down, sine alpha is positive, so we're just going to start with k sine alpha and k cos alpha. I'm going to take a different colour pen. So we're going to go, there is your sine alpha. Sine alpha is with cos. So I go over to the left and I underline cos and I think, right, what is with cos? Cos has got the number 5. So just repeat what I did again. I look at the right hand side and I go sine is with cos, and I move to the left and go cos is with 5. So k sine alpha is equal to 5. So it's the opposite. Whereas in the other ones you always went, well, cos is with cos, it's the opposite now. Sine is with cos. And then if I change my colour pen, I want cos alpha now. Cos alpha, that's not a different colour pen. So cos alpha is with sine x, and I underline the sine x is with 2. So they are my two little coefficient bits. Then I go do the wee Pythagoras bit to find k. So k is the square root of 5 squared plus 2 squared, which is 25 plus 4, which is 29, so you leave it as a third. The tan part, so tan alpha equals sine alpha over cos alpha. So we take the 5 and the 2 and put it as 5 over 2. And then, before I go to my calculator, I'm just going to decide what I'm doing with this. So all sine tan cos table. Sine was positive 5, so I tick all in sine. Remember, you're ticking where your things are positive. Cos was positive, so I tick all in cos. And tan was also a positive fraction, so I tick all in tan. This is your dream scenario. If everything's positive, it's just going to be what you get on your calculator. So you go to your calculator and you do shift tan of 5 over 2. And you get 68.2 degrees to 1 decimal place. Now, that is what alpha is because it was in the all box, so I don't have to do anything with it. So the last bit is to write your question back out. So 2 sine x plus 5 cos x can make the equation root 29 sine bracket x plus 68.2. That's not the clearest, so 68.2 degrees. Okay, so that's one with the sine expansion with a plus in the bracket. My second example is the sine expansion again, only this time it's got the minus in the bracket and it also wants it in radians. So first thing is to write out your question. So cos x minus root 3 sine x equals k sine cos minus k cos sine. Okay, so there's that symmetry, sine cos cos sine. Right, on this one, notice this here. There is a negative in front of your sine alpha. So we have negative k sine alpha when I go to write down my coefficients, and I have positive cos alpha, so k cos alpha. Right, here comes my different coloured pen. So negative sine alpha is with cos. What is with cos on the left? There's nothing there, so it's really a secret number 1. So negative k sine alpha is equal to 1. but there's a negative in front of that and I really don't want it. So all I'm going to do is I'm going to change that to positive and change that to minus. You may prefer to just rewrite this as k sine alpha equals minus 1 underneath instead of changing the signs, whichever works for you. So k sine alpha is negative 1. Cos alpha, so here is my cos alpha. Cos is with sine, and sine has a negative root 3 in front of it. So I have negative root 3 there for that bit. Then I can go do my Pythagoras. So I have the square root of negative root 3 all squared plus negative 1 all squared. And it's really handy just knowing anything squared turns positive, so the negatives really don't matter here. Root 3 all squared is just 3. 1 squared is 1, so that gives us root 4, so 2. So k is 2 this time. It's a nice whole number. This is a bit that gets a bit confusing when there's negatives involved. So tan alpha is going to be sine alpha over cos alpha. Sine is negative 1 and cos was negative root 3. So that just turns into 1 over root 3. Everything turns positive there. So tan alpha is positive 1 over root 3. Now, from your exact values, what gives you tan 1 over root 3? That comes from your 60-30 triangle, where this is 2, this is 1, and this is root 3. So 1 over root 3, the associated angle, the acute angle is 30. So, testing your exact values. I'm going to do all sine tan cos and decide what we're doing with that 30 degrees. All sine tan cos. So over on the left we said sine was negative 1. So I'm not doing all in sine, I'm going to do the opposite. So I'm going to do tan and cos. Cos was also negative, so I'm going to do the opposites. I'm going to do sine and tan. And then tan turned into positive, so I'm doing all in tan. So I'm doing the tan box. So alpha is 180 plus 30. Now 180 plus 30 gives us 210. So then to rewrite the question out, we have cos x minus root 3 sine x equals k is 2, and we were doing the sine expansion with a minus, so it's x minus, oh wait a minute, I've forgotten some, 210, it was a radians question. So 210, how do you turn radians in? Right, so the simplest way is to add a pi on the top and a 180 on the bottom. Simplify down, so let's get rid of the zeros. 21 and 18 are in your 3 times table, so that would give you 7 over 6. So this gives us 7 pi over 6. So it was radians and I nearly forgot there, didn't I? So 7 pi over 6. Another way is if you recognise 210 is 7 lots of 30, and you know 30 is pi over 6, then it's 7 pi over 6. So that's my example done. I hope you've understood this, and hopefully by the time you've done the cos ones, you start to understand the sine ones. And at the end of the day, the hardest bit is getting the sine alpha and the cos alpha and getting the numbers right. A wee tip though, if you're sat in the exam and you have a wee forgetful moment, just have a guess, right? You get a 50-50 chance of getting them the right way round. And if you don't get them, you can still pick up the further 3 marks if you do everything else the same. So see how it goes, but just remember what I say is I start right and I work from right to left, completely back to front, and go sine alpha is with cos. What is with cos on the left hand side? That's the way it works for me, that's the way I have to teach it. Okay, so I've got one more example here, and I always leave this one to the end because it is in radians and it's not exact values. So this means we're going to have to put our calculator onto radians mode when we get to the end bit. And I always leave this to the end until I know my class have mastered the other bits. So first thing we're going to do is write the question out. So we have 3 sine x minus 5 cos x. And then your expansion is the one with a plus. So k sine x cos alpha plus k cos x sine alpha. Now we've got a positive in this one, so we don't need to worry too much about our signs. So we've got k sine alpha and k cos alpha. Always look and see what that is first to decide whether it's positive or negative sine alpha you write down. Right, red pen. Sine alpha is with cos. Cos has got a minus 5 in front of it. So sine alpha is negative 5. Cos is with the sine and sine is with the number 3. So that equals number 3. Then we do the Pythagoras bit. So square root of minus 5 squared plus 3 squared. Well, that's just 25 add 9. Can't do anything with that, so it's 34. And we'll leave it as 34. Right, the tan alpha is sine over cos. So we have minus 5 over 3. I'm going to go my ticky bit first of all. So sine was negative, so opposites, tan and cos. Cos was positive, so all in cos. And then just to prove it's going to be the cos box, tan is negative, so opposites make sine and cos. So what you would normally do here in your calculator, you would go and do shift tan, get your answer, and you would take it off 360. But I have to go put my calculator to radians mode. Now, when I do radians mode for this one, and do shift tan of 5/3, remember never put a negative in your calculator, you come out with 1.03, and I'm going to go to 2 decimal places here, and you come out with 1.03. And normally we'd take that off 360, but we're not doing angles. So you have to remember that your all sine tan cos table actually has pi and 2 pi. So to get alpha, you are doing 2 pi, take away the 1.03. So go to your calculator and do 2 pi, or you could use 6.28 if you wanted. Take away 1.03 and you get 5.25. And then from there, that's us done. So to finish the question off, I rewrite that 3 sine x minus 5 cos x equals the square root of 34 sine bracket x plus 5.25. So remember, in your radians mode, your answer should be between 0 and 6.28 or 0 and 2 pi. So I hope that's helped. Thanks for watching. What I've got, if you want, you can finish now. I've got some examples. So these are all ones where you've got the plus expansion to make it nice and easy. So you could pause and try these, and then if you're still watching, you've unpaused and there's your answers. Okay, now I've done my angles to 1 decimal place for these ones. Then if you want, here's even more examples. These ones all have the negative expansions, which my pupils find a wee bit harder, and I've left them all in degrees just to make life a wee bit easy. And if you want to check them, there's the answers there. Thank you for watching. I hope you're managing okay with the wave function. Thanks, bye bye.